Hey, so in order to help you with your homework, I've decided to make a video explaining one of the mixture problems, which is example 7 on page 11 of your first packet. Now, I'm going to read the question and then I'm just going to take my notes over to a fresh sheet of paper. The question says, the manual for your new car suggests using gasoline that is 89 octane. So that's like 89% whatever, 89% octane. I don't know cars. In order to save money, you decided to use some 87 and some 93. So this is a little low and this is a little high. In combination with the 89 octane currently in your tank, in order to have an approximate 89 octane mixture. Assuming you have 1 gallon of 89 octane remaining in your tank, so I already have 1 gallon, and my tank capacity is 16 gallons, how many gallons of 87 and 93 octane should be used to fill up your tank to achieve a mixture of 89 octane? So the first thing I'm going to do is I'm going to take all this nonsense over to a separate sheet of paper because I don't want to just show you the textbook's work. I want to actually show you the work. Okay. So this is example 7, if I remember correctly. So what are the things that we have? We have want 16 gallons of 89 octane. We have 1 gallon of 89 and a 16-gallon tank. We have 93 and 87. That's messy. Those are what's available to us, 93 and 87. So I want to draw this out. We have different containers essentially, so I want to think of it like that. So I have 89 and I have 1 gallon of that. Plus, I'm going to have some 87, right? Some 87, and I don't know how many gallons of that yet, so I'm just going to leave it as a question mark gallons. Plus some 93, and that also I'm not 100% sure about. But when I add all these up, I should get some nice 89 octane, and it should be 16 gallons to fill up my tank. Okay, so I've got this already. This is what I want, 16 gallons of 89 octane. Now, if I want 16 gallons and I have 1 gallon, that means that I have 15 gallons left. So between the two of these should add up to 15 gallons. So let's see. If I want to know how many gallons of 87, I could always make this X gallons. But then, don't forget, these two need to add up to 15. So if I had 15 gallons between the two of these, minus how many gallons I have here, that'll tell me how many I have left. So what I'm saying is, if this is going to be X, then this one needs to be 15 minus X. Because if I took those, X plus 15 minus X, and I added those up, X's cross out, and oh look, I've got 15 gallons. So these two add up to 15 gallons, that's confirmed, so good on us for that. Now let's see. Like I said, these are percentages, so let's think of this as 0.89 and 0.87 and 0.93 and 0.89. Now this is just like one of those interest questions. Let's see. I have 1 times 0.89 plus X times 0.87, which I guess I'd rather write the 0.87x plus 0.93, 15 minus x, is equal to 0.89 times 16. And from here I should just be able to do a little distribution and solve. I'll finish the answer for you just so you can confirm that I'm correct with the example. Distribute this 0.93. I'm going to want to bring up a little calculator on screen. Any day now calculator. Okay. It's a little smaller. There we go. So 1 times 0.89 is just 0.89. 0.87x. This is going to be 0.93 times 15. So 0.89 plus 0.87x plus 13.95 minus 0.93x equals 0.89 times 16 is 14.24. Now I want to solve for x. So I've got a couple of x's on the left-hand side, right? Like I got this guy and this guy. So what I'm going to try to do is move the other stuff away from it. So I'm going to minus 13.95 minus 13.95 from here. Those will cross out. I'm also going to want a minus 0.89 and minus 0.89 from here as well, so that can cross out. 0.87x minus 0.93x is going to be negative 0.06x is equal to, I'm definitely going to want the calculator for this part, 14.24 minus 13.95 minus 0.89 equals negative 0.6. Negative 0.6. So if I divide both sides by negative 0.06, that's not a negative sign. And divide this by negative 0.06, then I've got the x all by itself. And this is going to be negative and negative cross out. 0.6 over 0.06 is going to be the same as 60 over 6, which is 1/10, 0.1. So x is 0.1. That's interesting. Oh, no. 60 over 6 is going to be 10. 60 over 6 is 10. Yeah. So 10 gallons. So that's x. 10 gallons. So that means if I go up here, let's see. X is 10 gallons. And 15 minus 10. X 15 minus x. Let's see if I can, there you go. 15 minus 10. That's 5. And hey, look, they add up to 15 gallons. 5 and 10 and 1 is 16. And the question is done. Now with this in mind, I'm just going to show you how I set up the other question. Question 51, the first of the mixture questions. And I have faith that you'll be able to figure it out and to finish it and to do question 52. So let's start here. 51, chemistry. For a certain experiment, a student requires 100 milliliters of a solution that is 8% HCl, hydrochloric acid. So our goal at the end is 100 milliliters of 8%. The storeroom has only solutions that are 5 and 15. So this is just like the gasoline, right? We want 8, but we have a little too high and a little too low, so we're going to mix them together to get something in between. Now, how many milliliters of each available solution should we mix to get 100 milliliters of 8% HCl? So here's how I thought to set it up. Our goal is 100 milliliters of 8%, right? So that's my goal over here. 8%, 100 milliliters. Here on the left, 5%. I don't know how many milliliters of that. plus 15%. I don't know how many milliliters of that, so I've represented those with question marks. But let's be honest. If they have to add up to 100, that means one of them is going to be x, and the other one is going to be 100 minus x. And I have faith that you can solve it from there, so good luck. See you in class.